Alright, so what I'm going to show you today is another method for doing something very similar to what you did yesterday. So again, it's just going to be a continuation from what we did yesterday. Left off on 22, start up on 23. And the method called synthetic division, as opposed to long division, is it's kind of like the relationship between the quadratic formula and factoring. The quadratic formula always works. Long division always works when you're solving a quadratic an equation to the second power. So if we're trying to solve or factor, in this case, an equation or expression to the third power, long division always works. However, there is another faster method, kind of like we have factoring, where you can just do a little x. We don't have to go through the whole quadratic formula just to find out that this thing factors to -2 and +3. The factoring is a lot faster. So this method, same thing. There's another method, synthetic division. It's kind of like the factoring. It's a lot faster. However, just like on the quadratic formula and the factoring doesn't always work. So you can try it, but it doesn't always work. Same thing here, this method, synthetic division. It works, but it can be very ugly if you don't use it on the right type of problem. So the first thing before we start on how to do it and what's involved is when to use it. So the most important thing for today is to understand that you only want to use this method if you have a simple divisor, like x plus 3 or x minus 2 or x plus even radical 2. Later on you'll find out. But we don't want like 2x plus 3 or -4x plus 5. We don't want something that's really complicated. Okay? To be even more specific, we really want this to be a 1. We don't want any number in here. So that's when you want to use this method. If you don't have a number in front of the x here, the divisor, then you don't really have to worry about much. This method is going to be a lot faster for you. Alright, so just pencils down in here. Since this is new, just kind of watch, observe what's going on, and then we'll next slide we'll have you practice. So here's what I'm going to start off with. Take your divisor, set it equal to 0, and solve for x. So in this case, x is going to equal -3. And why we're doing this will make more sense later in this chapter. Why do we want to do this? But right now we're just going to kind of learn the steps. So we're going to have this divisor. So instead of having x plus 3 in front, we're going to have just the -3. And the second part that's new is that instead of putting everything 2x to the third, 3x squared, inside here, we're only going to put the coefficients. So this method has no variables whatsoever. We just put -3 here instead of x plus 3. Instead of all this stuff, we're just going to put 2, 3, -4, and 15. And just like before though, if there was something missing, if this went 2x to the third minus 4x, we put a 0 in. So same idea there. But we just put a number. So this method is entirely variable free. Alright, so I'm going to draw a line right here. Drop down the first number right below the line, and that's the initial setup of the problem. So we have to solve right here. Whatever this is, set it equal to 0, get the number. That number goes in front. Bring the coefficients down. Insert zeros if necessary in between, and then drop that first number. So there's a little more work on the front end. We didn't have to do this before. Before we just copied everything down and started the long division process. So there's a little more setup here. But the nice thing is now that we've done all that work, the actual division process is much faster. Here's how it goes. -3 times 2, -6. Add it up. -3 times -3. 9. Add it up. -3 times 5, 15. Add it up. We're done. So yeah, if you blink, you kind of miss it. So our answer is going to be 5 there. We're going to have, this stands for 3x. This is 2x squared. So 2x squared minus 3x plus 5. Okay. If we did the long division, we'll get the same exact answer. So we know that this big old long thing equals x plus 3 times 2x squared minus 3x plus 5. So long division gets the same answer, but look how much less work there is. That's why this is a nice method. In the future, you're going to be checking on one equation. You're going to have a list of numbers. Like this one was -3. You're going to be able to generate a list of numbers that you need to do this with, and you might have to do 4 or 5 of these numbers on one problem, just to see if you get an answer of 0. Because if its answer is 0, it means that this is a root. That's the bigger picture. So there's a bigger meaning to this whole method and why we're learning it. It's not just something we're going to say, okay, that's nice how you do it, and then we won't see it again until the next semester final. We'll be using this a lot in this chapter. It's just later on, this is going to be one small step in a much bigger problem. So we want to get good at it. Yep.
Why is a 9 not a negative?
Why is a 9 not a negative? Because -3 times -3 was positive 9.
Oh, okay.
Yeah.
I thought you times that.
Right, yeah, you notice there's no changing of signs like we did before. It was like we dropped it down, we multiplied, then we changed both signs. We don't have to change signs here. We just add them up. Okay, so that's the idea. A little bit of setup, but the work overall is faster. Alright, so let's try you guys. Let's have you guys set this up. Try it on your own. Go ahead and write this down. Alright, let's take your divisor, x plus 2. No, sorry, x minus 2. Set it equal to 0. So the number we want to use is equal to 2. Yeah, we're seeing if this thing is a root. We're testing to see if 2, if we were to graph this thing, is 2 an x-intercept. So bring down the numbers. We have 3, -8, 11, and -14. And there's no variables missing. It goes from x to the third, x to the second, x to the 1, x to the 0, so we're not missing anything. Drop the first number. Okay, that's the initial part. Set it all up. Alright, ready? 2 times 3.
6.
Add them up.
2. Big 2.
2 times -2. Add them up.
7.
2 times 7.
14.
Add them up.
0.
0 remainder. Okay. So that means we have plus 7, 2x. Yeah, so 3x squared minus 2x plus 7.
How do you write the official answer to that?
That's it right here.
That's it?
Yeah. And again, what does it mean? What does this whole thing mean? If you're to graph this big old third power equation, it will cross the x-axis at 2. 2 is a root. That's what all this means. 2 is actually a root. So we talked about quadratic formula, factoring, completing the square, finding the roots. This is how we do it with anything that's to the third power, to the fourth power, to the fifth power. We can test whether it's a root or not without actually going through and doing a very, very complicated graph, we can figure out if it's a root or not. Question?
How do you write the remainder?
Okay, so the remainder works exactly the same. So sidebar, let's say this came out to be like 2. It'd still be the same thing. Just on the end of this, we'd say plus 2 over x minus 2. Yeah. So the remainder goes on top, the divisor goes on the bottom. So the same thing as your homework. Remainders work the same. Alright. Not too bad, not too bad. A little bit faster than what we did yesterday. See, now, when it comes here, just watch me on here, we could use the synthetic division on this problem. But there's a lot of small steps that are easy to forget, and that's why I'd prefer not to really do it. But if we did, we'd do the same thing, 3x plus 1 equal to 0. We'd find out x is equal to negative 1/3. Right? Then we'd have negative 1/3. And since we did some division here, we'd actually, well, we'll say that for later. We had 4, we'd have negative 5, we'd have 1, we'd have 7, I believe. Yeah. Okay. And you have to say, well, drop down the first number, and we'll be multiplying with fractions. So we'd say negative 1/3 times 3, and go through a lot of steps. And then our answer at the very end, we'd actually have to divide everything but by 3, except the remainder, and do all these little small steps in between, which we'd rather not do. So instead of trying to use synthetic division on this kind of stuff when we have a number in front, just going to actually just stick with long division anytime we have something in front here, just to avoid the big mess. Let's just stick with what we already know that works. Okay. So it's one of those things that, yeah, that's a nice method, but we're not going to start using it all the time on everything. So here we go, copy it down. We do not have to put plus 0. Somebody asked before that, well, there's no number on the end of this. Do we have to add like a plus 0 like we would if there's a variable missing? And the answer is no. You never have to add zeros at the end, only if they're missing exponents in between. Okay, so 3x times what is 3x to the 4th? X cubed. And then we get what? Plus, like that. Okay. Change both signs. Minus, minus. So we get negative 6 x cubed. Bring down positive x squared. Three x times what is negative 6x cubed? Negative 2x squared. There we go. And we get negative 2 times here, so that stays negative 2. Change both signs, positive, positive. We'll get 3x squared. Bring it down. 3x times what is 3x squared? Just x. So we get 3x plus x. Change both signs. We'll get 6. So here's when we do have a remainder, right? So we go plus 6x over 3x plus 1. Well, looking at this 6x over 3x plus 1, there's always a question on, does this simplify? Does that simplify? Okay. Because yeah, if it simplifies, you need to simplify. That's just the rule, right? But does this one simplify? Some people say no, some people say yes. Some people say, well, 2, right? Because, well, 6x divided by 3x is 2, and then I guess the 1 just goes on break, so it doesn't matter. You know, they just make up all these rules. So this is completely simplified. This does not reduce. Okay? That does not reduce at all. Now, let's look at a few of these and say, well, when does it reduce? How do I know if it does reduce? Okay. So here's an example. If this instead was plus 2, what I could do is factor a 2 out. See, when you're canceling factors. Factors are things being multiplied. So if you have addition here, and you can change it into multiplication by factoring 2 times x plus 1, now you can cancel it with something else being multiplied, like the 6 up here, 6 and the x. So now these do cancel, just the 2 and the 6, and you'd have 3x over x plus 1. Okay. And why do some people think that this cancels out? It's the same thing if I ask, do 2 negatives make a positive? Is that true or false? Do 2 negatives make a positive?
Sometimes.
Sometimes, yes. But there's a few people out there that say, yeah. It's like, no. 2 negatives make a positive when you're multiplying. 2 negatives make a negative when you're adding. You can't say yes. Yes, it does. So what they're thinking is of this. Well, if I just add 3x times 2, yeah, I can cancel this out. It's multiplying, right? Things cancel out, no problem. But if it's adding, it's not the same rules. You can't use the same rules on multiplying, 2 negatives make a positive, as addition, 2 negatives make a negative. So it's knowing when to use what rules. Kind of like the exponents, when do you add them, when do you multiply them? It's knowing the difference between the rules. So you're allowed to cancel. Cancel means, it actually helps to know the definition of cancel. It means it equals 1. There are factors that equal 1. So if you have a 2x squared on top and a 4y to the third on the bottom, it's the fact that there's a 2 here and a 2 here, and these equal 1. But it's all multiplication. That's what canceling is. So if you ever have something that's being added, you cannot use the same rules as if it's being multiplied. Okay. One more example, that if this was like 3x y squared squared, it's all multiplication inside. That's easy. Squared to 3, square the x squared here. If it's 3x plus y squared, it doesn't work anymore. You have to use the box. You have to use 3xy squared, 3xy squared, and it's a lot more involved work. So there is a difference if there's an addition and if you're adding. There's different rules. So going back to here, this is why you cannot reduce. You can't just cancel things out as addition. If there was no plus sign, wouldn't be a problem. Okay, so let's go to you guys just getting a start on your homework. By the way, why did I cross off or block off the odds here?
You should check them.
Yeah, so if you're one of those who said, what's 17? It's like, come on. You should not be waiting to right now to find out, did you do everything wrong last night? Did you do the first one, the second one, third one wrong? And instead of checking to see if you're learning it correct, just continue doing everything wrong? You should not be doing that. That's one of those things of, how come I'm not doing well in the class? I'm just not making sure I'm doing anything correct, and then just, taking a test hoping things go right. You should be concerned whether you're doing everything correct every single night. That's why we do so many book work, so you guys can actually track your progress and know before you show up if you got it or not. So yes, please check your odds as you go along. It might be more work, but then again, you'll have higher grades. Alright, so go ahead and get started on here. Remember when to use this method, like 23, 24, 25, 26, 27, 28, really good. Once we get to these where they have numbers in front or squareds, probably go with long division, okay?